Graphics applications like drawing editors and schematic capture systems that let users build complex diagrams out of simple components. The user can group components to form larger components, which in turn can be grouped to form still larger components. A simple implementation could define classes for graphical primitives such as text, lines, plus other classes that act as containers for these primitives. There's a problem with this approach. Code that uses these classes must treat primitive and container objects differently, even if most of the time the user treats them identically. Having to distinguish between these objects makes the application more complex. The composite pattern describes how to use recursive composition so that clients don't have to make this distinction. The key to the composite pattern is that abstract class that represents both primitives and their containers. For graphic systems, this class is graphic. Graphic declares operations like draw that are specific to graphical objects, and also access operations for accessing and managing its children, like add, remove, and get. The subclasses line, rectangle, and text define primitive graphical objects. These classes implement draw to draw lines, rectangles, and text, respectively. Since primitive graphics have no child graphics, Picture implements draw to call draw on its children, and it implements child-related operations accordingly, because the picture interface conforms to the graphic interface. Picture objects can compose other pictures recursively. The following diagram represents a typical composite object structure of recursively graphic objects. The goal of the composite pattern is to compose objects into tree structures to represent part-whole hierarchies. Composite lets clients treat individual objects and compositions of objects uniformly. The composite pattern defines class hierarchies consisting of primitive objects and composite objects. Primitive objects can be composed into more complex objects, which in turn can be composed and so on recursively. Whenever client code expects a primitive object, it can also take a composite object. It makes the client simple. Clients can treat composite structures and individual objects uniformly. Clients normally don't know and shouldn't care whether they're dealing with a leaf or a composite component. This simplifies client code. For the client, it is exactly the same. It makes it easier to add new kinds of components. Newly defined composite or leaf subclasses work automatically with existing structures, and it can make your design overly general. The disadvantage of making it easy to add new components is that it makes it harder to restrict the components of a composite. Sometimes you want a composite to have only certain components. With composite, you can't rely on the type system to enforce those constraints for you. You'll have to use runtime checks instead. Composite is usually used in user interface toolkits, graphical editors, where it's important to ignore differences from composed versus individual